Now we'll study about the data transfer microoperation. Data transfer microoperation of two types: register transfer microoperation and memory transfer microoperation. Register transfer microoperation means data of any register is copied to the another register when P control signal is on.
Memory transfer microoperation is further divided into two types, read and write. Here, read is the control signal and write is also a control signal. In read, when read control signal is on, the memory's data is copied to the R1, that is R1 is a CPU register, and when write control signal is on, R2's data is copied to the any memory location. This memory location is pointed by AR register. The AR is a address register.
This is implemented using a common bus. Why common bus? Because if we do individual connection from R2 to R1, any memory location to the R1, then there we need to um, uh, connect many wires. These wires will waste many spaces. So to avoid that, we use common buses. Common buses can be implemented using two methods. One is using masks and another using tri-state buffer. Now we'll see the common bus using mux. In this lecture, I will show how to copy the data of A's register to the B's register. In comment, you will comment me how to copy the data of C's register to D's register. To copy the data from A's register to the B's register, we need to first select the A's register output. That means to select, let me first give the name of any register in the binary form. That is 0, 0, 0, that is 0, 1, that is 1, 0, that is 1, 1. To select a register, we need to give select line 0, 0. So 0, 0 means this select line is copied to the this marks also, this marks also, this marks also. So 0, 0 means this I0 will be selected, this I0 will be selected, this I0 will be selected. That means A's output, to select the A's output, we need to give the A's output to the I0, all the I0. Okay. Now in the bus, we got A0, A1, A2, and A3. Now this A0, A1, A2, and A3 is available in the B's marks also, because this is connected, this is connected. B's register input also uh, getting the A's data. But to load the A's data into the B data, we need to on the load signal of the B. To on the load signal of B, we use another further a decoder. This decoder will select when which register to be loaded. Now we need to load the A's register to the B, and means we need to load on the load of B's register. That means 0 is goes to the select line of the decoder, and this line is selected. This line is connected to the load input of the B. Now the data of the A is copied to the B. Now let me know in the comment how to load the data of the C register to the D register.